Hello learners, this time we will going to talk about Avogadro's Law. In a gas, is a physical behavior is described by these four variables, namely pressure, volume, temperature, and amount or mole. In this video, we will have Avogadro's law, which is concerned in relationship of volume and amount of gas. This condition is true when temperature and pressure is constant. Avogadro's law was formulated by the famous scientist Amadeo Avogadro in late 1812. Hi everyone, my name is Sohel Escalipa, a grade 12 senior high school of SDA College, Cotabato, and I'm going to introduce about informations of Avogadro's law. The air we breathe and move through daily, the helium in our birthday balloon, and the methane used for home heating are all common examples of gas. Gas is one of the main states of matter along solid and liquid. Gases are everywhere, and this is good news and bad news for chemists. The good news is, when they are behaving themselves, it's extremely easy to describe their theoretically, experimentality, and mathematically. The bad news is they almost never behave themselves. Gas is one of the four fundamental states of matter. That is no fixed shape and no fixed volume. The shape and volume of gas is determined by the shape and volume of its container. However, unlike a solid, a gas will escape if there is no lid on its container. The particles in gas have a great deal of freedom of movement and do not have an order arrangement. This is because the force that attract these particles to each other are weak or absent in the gas phase. The formal physics description of a gas is a substance that does not have a definite volume, also called a fixed volume, or a definite shape. Instead, a gas will take a shape on its container because gas molecules can move freely past one another. An important measurement to describe a gas is pressure. The pressure of a gas is the force per unit area that the gas exerts on its container. More pressure leads to more force, and vice versa. Another key characteristic of a gas is its temperature. A temperature of a gas is defined as a measure of average kinetic energy per molecule in the gas. Because all molecules are vibrate, they all have some amount of kinetic energy.
Hi everyone, I am your Matir S. Balaogan. Both pressure and temperature are needed to determine if the state of matter is gaseous, as in the gas law. We have 5 different types of gas law. That is, the Boyle's law states the pressure P of a given quantity of gas varies inversely with the volume via constant temperature. The Charles law states that the volume of a gas equals a constant volume multiplied by its temperature as measured on a Kelvin scale. The Gay-Lussac's law states that the temperature of gas is a given mass of a varies directly with the absolute temperature of the gas when the volume is kept constant. The Avogadro's law statement that under the same condition temperature and equal to volume of different gases contain an unequal number of molecules. And lastly, the combined gas law states the ratio of product of pressure and volume and absolute temperature of a gas is equal to constant. However, we will focusing on the Avogadro's law and discuss what is law all about. First thing is, who is Amedeo Avogadro? Amedeo Avogadro was an Italian scientist most noted for his contribution to molecular theory now known as Avogadro's law, which states that in the modern version of it is equal volume of all gases at the same temperature and pressure have the same amount of molecules. Avogadro's law is also known as Avogadro's principle of Avogadro's hypothesis. The main application of Avogadro's law or determination of the molecular formula of gaseous compound establishes a relationship between the relative vapor density of gas and its relative molecular mass, establishes the relationship between gram molecular weight and volume of a gas at STP.
Problem solving. In mathematical definition, the law can be written as V over N equal K, where V is the volume of the gas, N is the amount of substance of the gas measured in moles. K is a constant for a given temperature and pressure. This law describes how under the same condition of temperature and pressure, equal volumes of all gases contain the same number of molecules. For comparing the same substance under two different sets of conditions, the law can be usually expressed as follows. Initial volume over initial amount of moles equal final volume over final amount of moles. The equation shows that as the number of moles of gas increase, the volume of the gas also increases in proportion. Similarly, if the number of moles of gas decreases, then the volume also decreases. Thus, the number of molecules or atoms in a specific volume of ideal gas is independent of the size of the molar mass of the gas. The specific number of molecules in 1 gram mole of a substance, defined as the molecular weight in grams, is 6.02214076 times 10 to the power of 23, a quantity called Avogadro's number, or the Avogadro constant. Initial velocity over initial amount of moles is equal to final amount of moles. Where initial velocity is 10.0 liter, final velocity is unknown. Initial amount of moles is 0.80 mol and final amount of mole is 0.20 mol. Rearranging the equation to solve for the unknown volume, we get final velocity is equal to initial velocity times final amount of moles all over the initial amount of moles. Now, we can substitute initial amount of moles, initial velocity and final velocity into the expression and solve for final velocity is equal to 10.0 liter times 0.20 moles all over 0.80 mol, and we get an answer of 2.5 liters.
For example, the molecular weight of oxygen is 32.00, so that 1 gram mole of oxygen has mass of 32.00 grams and contain of 6.02214076 times 10 to the power of 23 molecules. Another example is this: say you have 5.00 L of a gas which of contain of 0.965 mole of molecules. What will be the new volume of the gas if the quantity is increased to 1.80 mole, assuming pressure of temperature are held constant? In this case, a good choice for selecting the appreciate form of the law for the calculation is initial velocity and final amount of moles is equal to final velocity and initial amount of moles, where the initial velocity is equal to 5.00 L, final amount of moles is equal to 1.80 mol. We put the initial amount of moles is equal to 0.965 mol. We write the equation to this: X is equal 5.00 L and 1.80 mol slash 0.965 mol to solve it. Then as we compute, the answer is X is equals 9.33 L. Example 3.0, if a 10.0 minus L balloon contains
0.80 mol of a gas, what will be the volume of the balloon that contains 0.20 mol of the gas if temperature and pressure remain constant? To calculate the final volume, we can use the following relationship.
Velocity over initial amount of moles is equal to final velocity over final amount of moles, where initial velocity is 10.0 liter, final velocity is unknown. Initial amount of moles is 0.80 mol and final amount of mole is 0.20 mol. Rearranging the equation solved for the unknown volume, we get final velocity is equal to initial velocity times final amount of moles. Now, we can substitute initial amount of moles, initial velocity, and final amount of moles into the expression and solve for final velocity is equal to 10.0 liter times 0.20 mol over 0.80 mol, and we get an answer of 2.5 liters.
Hello, I am Israel. I am of type 21 and here I will demonstrate an experiment of how Avogadro'S Law is read.
How to blow up a balloon with baking soda and vinegar. In this video, we are blowing up a balloon with carbon dioxide. This is a great experiment to show you how acetic acid, which is vinegar, and sodium bicarbonate, which is baking soda, react to form sodium acetate and carbon dioxide gas. The rapid release of the carbon dioxide gas in the reaction pressurize the plastic bottle and cause the balloon to inflate. So why the balloon is inflating? When you combine baking soda and vinegar, the two chemicals undergo a chemical reaction. A chemical reaction is when two chemicals reaction to each other or react to each other to form a new chemical or chemicals. In this case, baking soda and vinegar combine to form water. Some chemical called sodium, acetate, and carbon dioxide. Carbon dioxide is a gas and its chemical filling the balloon. The materials we need for this experiment include the empty bottle or the plastic bottle, the vinegar, the tablespoon, the balloon, and of course the baking soda. First, take off the cup and pour the vinegar into the bottle. Then pour the baking soda into the bottle. Once the baking soda is quickly, put the mouth of balloon over the bottle opening. Gently shake the baking soda mixture and observe what happened. See? The balloon is inflating.
Thank you.
Thank you.
Thank you for watching.